Okay, so we're going to move on to another subject now, which is a big important subject coming ongoing, looking into the future, which is foreseeing digitally at the mill, or for another word for it is IoT, industrial IoT, Internet of Things, Industry 4.0. I know that Metsä's doing a fair amount of it. It's some of the mills. But how important do you see that as going to the future, which is basically data capture, management, helping you to run the mill effectively? Ismo, can we start with you?
We had in this industry the quality monitoring manner so that we take samples from our products and we send them to the laboratory, refining laboratory, and then they make refinings, they got the results, they send the results to us, and we looked at what is the quality. In many cases, when we got these results, our customers has used this product. So what we need of these kind of results. And we sat down in our company and we think about what we can do better. This is not the way how we can monitor the quality and serve our customers. And we decided so that we start to collect the crucial information in our process so that we can combine them to one quality index. And then we make a verification with our customer that it is same that the refining results. And we got the online quality measurement. And I'm pleased that Andritz take that quality index to their product portfolio, because I want that this will enlarge in our industry, because we can, in this way, we can serve our customers better.
Yeah. There's a lot of data.
Yeah.
The challenge is to change data into information that we really can use.
That's right. Yeah.
And that's the systems we are looking for. And I think for in future, for at least for paper making, it's crucial to have it. You already mentioned the condition of the systems has to be monitored. So that you are in time that you can organize a pit stop for a quick change, and yet you can go on producing. But in the time that the condition is not perfect, you have different conditions to the normal conditions, which forces you to find other settings to make the same quality of paper and so on. So it's extremely important that we really use the data to find optimum settings every time again, every minute again.
And repeat the perfection.
Yeah. Yes, because you have to make the right quality at at the lowest cost price, at the highest performance. Always, not once in an hour.
No, hitting that sweet spot every time. Yeah.
And I really would like to underline your remark on inline sensors, because it's really a disadvantage measuring it only once an hour or whatever. You need to have soft sensors in the system. For that we are really developing. So data collection is already quite far, but we are now developing advanced process controls, so to be sure that you're always in the same quality.
Yeah.
Inline sensors help, and they help to calibrate your advanced process control.
Yeah.
But they also have the challenge of inline sensors is to make them reliable. As soon as you have one time a mismeasurement, operators will directly say, "Oh, it doesn't work." So, and that's a big challenge. Perhaps I have to look to Andritz again. But that's a big challenge. Develop inline sensors that we are really that we really can trust.
Already from 10 years ago, we were able to collect more information from the mill processes, what we were able to utilize. And that's really the limit, that we have to have robotics and software to analyze all those things what we are able to collect, and then giving us information when something is abnormal. And maybe even guessing, okay, this is now abnormal with this valve position. You should get bigger flow normally in this pipe. There is abnormally and the valve is wrong. Or by this caustic flow you should get different kind of pH based to the history. So either your caustic flow is wrong or then your pH measurement is wrong, either or. But that kind of analysis should come automatically, and that's, I think, now under development, and it's coming more and more common. And then now we are going to get in the coming future really use for the data. Yeah. What we have been able to collect already 10 years ago, but we have had no manpower. It have not made sense to waste human work for screening data, which is more or less no actions at all, except once or twice per year. and that have to be so that there is some kind of robotic to analyze all the data, and then it gives us value.
To summarize a bit what you have said here, and that goes very much along with what our experience is you have 3 areas. You have the preventive maintenance, you have to monitor the issues involving unpredictable shutdowns, like monitoring of bearings and shafts, etc. You have the quality measurement, and you have the optimization of the processes, using less chemicals, not too much, which you may have done before, or you level out the imbalances in the processes. And I think that all depends more on the sensors and on the computers analyzing the data. I think that's the conclusion, and there are systems there. And Harry, you have also in your service area, you have the OPP concept where we actually offer these things there. So, I mean, I'm not a technologist. I cannot predict the steps to be taken, but these are the directions we see in customer discussions. We see it in our own organization. That's where we are trying to improve. Customers are asking for new ideas here. Then there will be, at the end of the day, maybe a discussion on who owns the data. That's another thing. But okay, I leave that.
How much data you will allow to go to your competitors' direction with the suppliers?
Harry, anything to say around IoT?
Yeah, actually, so in the past, so that when we were developing sensors for pulp and paper industry, so that they were developed for predictive mainly for predictive maintenance, so that we know in what condition the machines are. But now during the last 5-10 years already perhaps, so that we have started to develop sensors for proactive maintenance, so that everybody knows that when it was predictive maintenance, so that we tried to get rid of the unplanned shutdowns. That was the main thing. But when we now talk about the proactive maintenance, so that we are more concentrating on the process itself, so that we want to run with the maximum capacity and with the prime quality, and the new sensors are helping us there. And this Fox is really good example about that. That is a quality index, what Ismo just mentioned. And before we bought the rights for that one, I called to their customer, to end customer, to paper machine person, and asked, is this really supporting her? It was a lady, and she said, yes, that is really great tool, so that when they are buying fibers for Metsä Fibre, they know exactly how to run the paper machine, when they know what kind of pulp they are getting. But if they are getting the pulp from competitors, they must use extra virgin fibers that is extremely very expensive for them, and that's why they would like to get always with the Fox index pulp coming in, and they say that it's 2% difference in secondary fiber usage when it is Metsä Fibre fiber or competitors fibers.
For paper makers to have a safety margin in amount of softwood is quite expensive exercise. So that's why they should know the quality, and the quality always should be the same. That's for sure.
We call it flatlining. You can earn a lot of money by that, because you have now this variation. You can reduce that. You can go to the bottom limit, and that's a huge saving. one of our most advanced mill in that view has even installed now an online cost price. So they have done a measurement on every part of the mill, and they know exactly energy consumption, chemicals, everything. And when a paper maker makes an adjustment, he directly sees cost price goes up or down. That's what we would like to have. But once again, for that you need sensors. But what's more important is reliable sensors. Because if there's a small mistake in a sensor, you go in the wrong direction.
We have done that also for our pulp mills for chemical consumption, so that the operators are able to see immediately effect in cost when they are adjusting chemical amounts, and that's one way to motivate them also, so that they recognize that they are making important decisions when adding or reducing chemicals. It's much more easy to understand euros.
Yes.
It's good unit.
Well, I'm afraid, gentlemen, we've run out of time, but I'd like to say thank you very much. It's been a really, really good discussion, and I'm sure we'll be having another one in Spectrum at some point. So thank you very much indeed, and good night.
Thank you.